What is going on? It is Thursday, April 28th, 2022. I am back. It's welcome to Coding with Chef, and thanks for watching preemptively. Here to bring you another coding problem and trying to bring you a coding problem every morning if I can. It's good practice for me, it's good practice for you, and yeah, so let me know what you think about these videos. Like, subscribe, comment, etc. And yeah, let's get started. Today's a good morning, by the way. I'm prefacing it, it's kind of windy, and I'm just gearing to get up and start doing something. So rings and rods, okay. 2103, this is an easy problem, okay. And at first glance it did remind me of the canonical Towers of Hanoi problem that is introduced in computer science textbooks, and I'm sure it's trying to call out to that, at least thematically, but it's not. It's a different problem. So there are n rings, and each ring is either red, green, or blue. The rings are distributed across 10 rods labeled 0 to 9. You are given a string rings of length 2n that describes the n rings that are placed onto the rods. Every two characters in rings forms a color position pair that are used to describe each ring, where the first character of the ith pair denotes the ith ring color, and the second character of the ith pair denotes the rod that the ith ring is placed on, 0 to 9. For example, R3G2B1 describes n equals 3, a red ring placed onto the rod labeled 3, a green ring placed onto the rod labeled 2, and a blue ring placed onto the rod labeled 1. Return the number of rods that have all three colors of rings on them. Okay, all three colors of rings. So here's the example. Okay, again, you have 10 rods, right? 0, 1, all the way up to 9. You can have 3 rings on each rod, right? You can have multiple rings, I guess an infinite number of rings on each rod, right? Interesting problem. Alternative constraint would be the total number of rings you can have on each rod. Anyway, but you can have as many as can be, and they can all be of a different color, and they can also be the same color. And the ideal goal is to find out which rods have at least all the colors of the rings. And there's 3 colors of rings. But there can be more than 3, I guess. But in this case, constraint case, there are 3. So the rings are B0, so 0, 6, B6, G0, R6, R0, R6, G9. Okay, so 2 red rings and a blue, for instance, are on the 6th ring, and all 3 colors are on the 0th ring, and on the 9th ring you just have 1 green. That was this one here. So the answer would be would just be return 1, because that's the only rod that you have all rings on. So I guess when we look at a problem like this, it should be pretty straightforward, right? And here's another example where you have all the colors of rings only on 1 rod and 1 ring on the 9th rod. Okay, so yeah, this should be pretty easy overall, right? The first thing to do would be, I would say, since we're dealing with rods, right, and we're looking for the total number of rods per ring, or rings per rod, right, my first instinct is to make a HashMap, and the HashMap's key is going to be the character which corresponds to the rods. Now, I could make that an integer, right? But these are all coming back in a string of rings, so each element of that string is a character, so it makes it easier that way. No need to do that conversion. Okay, and so what I'm doing here is I'm adding a hash map here, because this hash map's max size is going to be 3 for each of these characters. So you could use a matrix or something like that even. It doesn't matter. This hash map just prevents me from adding duplicates, because each rod you're going to toss a ring, and the ring, the next ring, the subsequent ring could be of the same color, but this map is just trying to give me the total possible unique colors. So if I add 2 reds to this map, I'm only going to have 1 R represented here, right? Remember, if you add map that add I'm just doing pseudocode here. Add R. In the end, you're going to have map of R. You're going to have only one R in there, or let's call it a set, right? Set, just to be more correct. Set add R. Set add R. Set is going to contain only R. It's not going to contain 2R, for example. Okay, so just keep that in mind. It's basic, but we just want to remember that. So all colors in all colors, color rods equals 0. HashSet character rods equals new HashSet. So what is this guy? And so every time I find a rod, I want to mark it off. Now there's many ways of doing this. To me, this is the easiest way, and you'll see why in a bit. So now that I have my data structures in place, we're going to return all rods. Every time I find a rod that conforms to the parameters, which means it has all 3 rings, I'm going to return that. So I less than rings dot length I plus equals 2, because I'm iterating, so I'm going to iterate through the string 2 at a time, because the string's length is 2n, and n being the number of rods, sorry, the rings. The length 2n that describes n rings that are placed onto the rods. Okay, so yeah, there's n rings here. So every pair is going to be a rod and a ring color. So that's why we iterate in a block of 2. Okay, so now I want to represent color equals rings that are at I. I plus 1. So we have the rod and color. So if we have B6, B5, we have B is this guy and 5 is this guy. Okay. Marker rings on equals rod map dot get or default rod. Okay, so this is us initially running across a particular color. Okay, so if I initially run across a rings value, okay, if I initially run across, sorry, a rod, right, I'm going to get the set for that rod, and if the set doesn't exist yet, I'll create a new hash set, and this will just be the set of rings, okay, and then on rings, remember, this is the whole reason of adding this interior hash set. The goal is to just add the color to that set to see, again, the sets, this particular internal set is going to be at most ever looking like whenever a ring is added. So if the green ring was never thrown, a single green ring, or if 10 blue rings were thrown, it'll still look like this. Okay, that's the idea. We always want to get the total unique values. Is on dot size equals 3. Okay, so because RGB is of 3, size 3, that means we have all the colors represented for a particular rod. We want to do rods add rod. Now, why am I using this extra set to do that? Can I just count? Well, you're going to have this, since we're using this map, we could run across this map multiple times. Every time we get this map, then we'll be adding only to this map. We're not subtracting, and we can have multiple times when the same rod is called for different rings, and that will be counted as size 3, and that will throw off our calculations. It'll add extra rods, so we don't want to do that. Rings on. Okay, and let's see, return, so we want to return rods dot size. Okay, now, we could return all color rods. No, we don't need all color rods. Let's get rid of that. Okay, let's try this. This should be a set. Okay, and there you go. All right, so that worked. Okay, so yeah, if you have any questions on how this works, it's a pretty easy problem. I've written the discussion out in the Leetcode discuss section, and this is my work essentially here. If you want to take a look at the solution, I write down the solution for every problem, and yeah, it should be pretty easy. So thanks for watching. Have a good day. I'll see you next time. Oh, by the way, you know what? One thing I forgot to do before I go. What's the space complexity of this? The space complexity is going to be constant, right? Well, no, it's not going to be constant. The space complexity of this rod set is going to be constant because it's going to be at most 10, right? Because there's at most 10 rods. It was put as the constraint in the question. The space complexity is going to be O of the number of characters, or the number of rings, right? So O of n times 2, which is O of n. Okay, so that's, yeah, that's it. Just wanted to add that in there. Okay, great. Thanks a lot. I'll see you around. Have a good day.